All right, in this video, we're going to be looking at Chapter 6. Let's start right in here with number 32. So for this one, they're asking us to name 4 different pairs of polar coordinates that represent the polar point A. Now, they didn't give us a coordinate for A or tell us where the exact location is, so we can assume that this point is at, if we go all the way around the unit circle, we can think of that as being at 7 pi over 4 radians. Okay, so in a positive direction, and we're going 3 rings out, so one of the values would be 3, 7 pi over 4. Now we could get to that same spot by going in a negative direction, so that would bring us to the same vector, the right vector, but we would just be going in the negative direction, so it'd be negative pi over 4. I might be wondering, well, how do we get some other values here? Well, oops. Here's what I'm going to do. I'm going to erase these. Whoops. So remember, it's on this, that vector's on this pole that goes in both directions. And so we could come up with a value going this direction. So if you did that, that would be at 3 pi over 4. But that would be on the right pole, but in the wrong location. So we'd have to go backwards 3 units if that was the case. So it'd be negative 3 and 3 pi over 4. And finally, the other one that we could get to would be going this direction in the negative direction. So if you did that, that would be negative 5 pi over 4. And then again, we would go backwards 3 units. So it would be a negative 3, negative 5 pi over 4. So those are 4 different pairs of polar coordinates that represent that point A. So here we're doing some graphs. So this one, it says this graph where r equals 3. Remember, this is going to be in the shape of a circle where the radius is 3. So 1, 2, 3, we would have these 3 key points here. And we'd connect them to make our circle. Now this one, remember, we'd have to take our A and B value and divide those. And we get 2/3. So if you remember from your chart, that means that this is going to be a loop. And to figure out those coordinates, I'm going to create a table of values, where for theta, we're going to use our key points here at 0, pi over 2, pi, 3 pi over 2, and come back full circle back to 2 pi. So when we take and put these values in for theta, we're going to simplify. So the cosine of 0 would be 1. So then we'd have 2 plus 3, which would be 5. When theta is pi over 2, well, cosine of pi over 2 is 0. So 3 times 0 is nothing, so we would just be left with 2. At pi radians, that's where the cosine of pi would be negative 1. So 3 times negative 1 would be negative 3, plus 2 is negative 1. At 3 pi over 2, that's where cosine is 0 again. So we would have just 2 here. And at 2 pi, that brings us back to where we started at with 5. So let's plot these points. So this first one, we're going to go with 0 radians, and then we're going to go out 5 units. So that would be right here. Next one, at pi over 2 radians, we're going to go out 2 units. At pi radians, we're going to go backwards 1. And then at 3 pi over 2, we're going to go down 2. And then it brings us back to where we started from. So remember, this is going to be in the shape of a loop. So it would look something like that. Now this one is just going to be a linear. Again, if you want to remember the rules for those, go back and look at that lesson in Chapter 6. But this one, pi over 4 radians, is just that line there, that diagonal. Let's look at number 36. So for number 36, this is one of those. It's going to be a rose curve. So the first thing I recognize is our n value here is 2, so that's even. So remember, if it's even, the number of petals equals 2 times whatever n is. So in this case, there's going to be 4 petals. And then the fact that it starts, or the fact that it's a cosine function means it's going to start at 0. If it was sine, remember it started at 45 degrees, but here it's going to start at 0. And to figure out what the degrees are going to be between each petal, we take 360 divided by the number of petals. There's 4 petals, so there's going to be 90 degrees between each petal. and the length of the petal is going to be what this value is, so the length of each petal is going to be 4. So going out at starting at 0 degrees, 1, 2, 3, 4, this will be my first petal. And then we're going to go 90 degrees more, 1, 2, 3, 4. There's our second petal, and then 1, 2, 3, 4. Oops. There's our third petal. 1, 2, 3, 4. Here's our fourth petal. All right, let's look at number 37. So it's Gretchen Askren as an outfielder for the West Chicago Wildcats. Is 215 feet from home plate after catching a fly ball. The runner tags third and heads for home. Gretchen releases the ball at an initial velocity of 75 feet per second and an angle of 25 degrees with the horizontal. Assume Gretchen releases the ball 5 feet above the ground and aims it directly in line with the plate. Call that plate S. All right, so we're going to write two parametric equations that represent the path of the ball. So remember, we have one dealing with the horizontal distance. We'll say x of 0 equals that initial velocity, which is 75 feet per second, so 75 times the cosine of the angle of 25 degrees times t. When you go to simplify that, if you just, since we're multiplying here, you can simplify that by multiplying 75 times the cosine of 25 degrees, and you get 67.97. So I'm just going to simplify this to say that the horizontal distance would be 67.97 times t. All right. So for the vertical distance, now remember technically, so it would be negative 16t squared, but remember it's negative 16t squared because we're taking negative 1/2 times 32. And we use 32 since everything's in feet, so that means acceleration due to gravity would be 32 feet per second squared. So it'll be negative 1/2 of 32 times t squared plus that initial velocity of 75 times the sine of 25 degrees times t plus 5. Let's simplify that. So like I said, we'd have negative 16t squared. And the 75 times sine of 25, we can simplify that to be 31.7 plus 5. So those would be the two equations we would use. Now I'm going to skip B. We're not going to worry about that. So let's go down to letter C here. It says, how far will the ball travel horizontally before hitting the ground? Now the problem is, and we need to use, in order, so that's a horizontal distance. In order to use that horizontal distance formula, we need to know how long it's in the air for before it hits the ground. So we're actually going to have to hit, or we're going to have to do letter D first and find out when the ball will hit the ground. That's the time. And then we can use that to figure out how far it's going to travel horizontally. So let's do that. So when will it hit the ground? We're going to use the quadratic formula for that. So I'm not going to scroll up and down here, but looking at your sheet, looking at your answer for part A, we're going to use a quadratic formula on the quadratic part. So to be t equals the opposite of b, so negative 31.7. Going to be plus or minus the square root of b squared, so 31.7 squared, minus 4 times our a value, which is negative 16, times our value for c, which is 5. All of that's over 2a, so it's all divided by negative 32. So you would just do that in a couple of steps, and when you do that, you're going to get two solutions for t, one of which is a negative 0.145, and the other is a positive 2.12. Now this one we don't care about, we want the positive value, so that means that it's in the air for 2.12 seconds. So we can use that to answer part C. So we know the time is going to be 2.12 seconds, so how far will it travel horizontally? We would take and use that horizontal formula, 67.97 times our value for t, which is 2.12, and that gives you your answer, which is 144.1 feet. All right, let's look at E and F. So for E, it says, what is the maximum height of the trajectory? So we're trying to find basically the vertex. In order to do that, we need to know part F. We need to know when, we know the time it will reach its maximum height. So remember, for that, we're going to use the opposite of b over 2a. And again, b is 31.7, so it'll be the opposite of negative 31.7, divided by 2 times negative 16, so it'll be, again, divided by negative 32. So when you divide those out, we get a positive 0.990 seconds. So just under 1 second is how long it would take for it to reach its maximum height. So to figure out what the maximum height would be, that's where we're going to use the formula for the vertical distance. So we're going to take negative 16 times our value for t squared plus 31.7 times our value for t plus 5. When you do that, you get your answer of 20.7, so it's 20.7 feet is the maximum height. All right, let's look at number 38. This is a rectangular point. We're going to try to find the standard form, the polar form, and the trigonometric form. So remember the standard form, we just put that in a plus bi form. This is our value for a, this is our value for b. So it would just be negative square root 3 over 2 plus our b, which is 1/2, times I. That's all you got to do for that. And to get our polar form, remember that's r and theta. So to find r, we're going to take the square root of negative square root of 3 over 2 squared plus 1/2 squared. Now to simplify that, when you square a negative, it becomes a positive, and the square root of 3, when you square that, you get a positive 3. Oops. And 2 squared is 4. So you square both the numerator and the denominator. And so this would end up being square root of 4/4, or just 1, and the square root of 1 is just 1. So r would equal 1. So now to find theta, we do the inverse tangent of b over a. So it would be the inverse tangent of 1/2 over negative square root of 3/2. So we have to do a little bit of work here. We're going to do the keep, change, flip. So you'd have 1/2, change this multiplication, flip the other one, so we'd have negative 2 over the square root of 3. So these would cancel out, leaving us with negative 1 over the square root of 3. Rationalize the denominator. We get negative square root 3 over 3. So now what we have really here is the inverse tangent of negative square root 3 over 3. Remember, we got to figure out which quadrant that's in. So remember our 3 values from quadrant 1. We have square root of 3, 1. So this would be the same as square root 3 over 3. We want to find a negative square root of 3 over 3. So remember, tangent is negative in quadrants 2 and 4. And since our rectangular point is where x is negative and where y is positive, that tells me it's going to be over here in quadrant 2. So that's going to be at 5 pi over 6. So now to get the trigonometric form, remember that's in this form, r, we have cosine of theta plus I sine of theta. So it would be 1 times cosine of 5 pi over 6 plus I sine of 5 pi over 6. So we would leave it in that form. So if you simplify it, it would put it back into standard form. All right, let's look at number 32. Write the rectangular equation as a polar equation. So the first thing I recognize is on the left side there, we can factor out a 2. If we do that now, x squared plus y squared, remember that's the same as r squared. And remember, y is the same as r sine of theta. So what I'm going to do is I'm going to subtract that from both sides. We could have done that at the beginning, I suppose. And now if I divide everything by r, we'd be left with 2r minus 5 sine of theta equals 0. And if so what we did here is we divided everything by r. And now I'm going to solve for r. So I'm going to add 5 sine of theta and divide by 2. So that would be your polar equation. That's all we'd have to do for that. All right, so for this one, they're asking us to find this different forms. Now this is in polar coordinate already. So what I'm going to do first is I'm actually going to start with the trigonometric form. So that's going to be the easiest. We just plug that in, remember? So we'd have -8, so that's our r value, times the cosine of -pi/4 plus I sine of -pi/4. That's the first thing I would do. The second thing I would do is I'm going to simplify that and get that into standard form. Because watch what happens. So the cosine of -pi/4. So that's going to be in quadrant 4, where cosine will be square root of 2 over 2 and sine will be negative square root of 2 over 2. So we're going to have -8 times the square root of 2 over 2. Then it would actually be minus square root of 2 over 2 times I. Now if I distribute that through, I divide, so I'm going to end up dividing by 2 on each of those. We'd end up with -4 square root of 2 minus 4 square root of 2i. So that's actually our answer in standard form. All right, now let's get this in rectangular form. So rectangular form, that's going to be the easiest since we already found these. It's just going to be negative because our a value and b value are here, so it's going to be a -4 square root of 2 and a -4 square root of 2. We can do it in that order for number 40. All right, so this one we're going to be multiplying these two values and dividing these two values, or I'm sorry, these two vectors. And so remember, when you're multiplying, you're just going to start by multiplying the r values. So we're going to take 5 times -2, which is -10, times the cosine. And then what we're going to do is we're going to take and add our thetas together. So 20 plus 45 would be 65 degrees. So remember, when you're multiplying two vectors, you multiply the r values, but you add the thetas. So then when we go to divide the two vectors, we're going to divide the 5 and the -2 to get -5 halves. Or if you said -2.5, that's fine too. And now we're going to subtract the values for theta. And 20 minus 45 is -25 degrees. So it's important that you take and do the 20 minus the 45 and not the other way around. Plus I sine of -25 degrees. That'll be your answer for number 41. Let's look at 42. So here we're going to use de Moivre's theorem to find the indicated power of the complex number. So for this one, we're going to apply that power to the 5. So it'll be 5 cubed, which I'll simplify in a second, times the cosine. Now what we're going to do here is we're going to take that value for n, which is 3, times 5 pi over 3. And 5 cubed is 125. When you multiply these together, we're just left with 5 pi. So it'll be the cosine of 5 pi plus I sine of 5 pi. All right, we're going to change this one up a little bit. So instead of finding and graph the 4th roots of the one that they gave us here, I'm just going to change this to be 81 times the cosine of 120 degrees plus I sine of 120 degrees. All right, so let's see how we would do this one. So first off, the 4th root of 81 is just 3. So since we're dealing with degrees, instead of taking 120 plus 2 pi k, 2 pi is the same as 360, so it'll be plus 360k, all divided by 4, plus I, sine of the same thing. And now let's simplify that. So it'll be the cosine of, so 120 divided by 4 is going to be 30 degrees. And 360 divided by 4 would be 90 degrees. All right, so now we're going to do this when k equals 0, when k equals 1, when k equals 2, and when k equals 3. So we're going to do this 4 times. I always start with k equals 0. So we have 3 times the cosine. So if I put 0 in there for k, 90 times 0 is 0, plus 30 would be 30 degrees. If we do it for 1, we'd end up with 90 times 1 is 90, plus 30 is 120 degrees. Oops. And when we put 2 in there for k, we'd have 180. So plus 30 would be 210. So we'd have 3 times the cosine of 210 degrees plus I sine of 210 degrees. And then lastly, when we put 3 in there, we'd end up with 300 degrees. So it'd be the cosine of 300 degrees plus I sine of 300 degrees. All right, let's look at number 44. It says a vector has a magnitude of 3.4 centimeters and a direction of 27 degrees. Find component forms. Remember, that's just where we take r times the cosine of theta, r times the sine of theta. So in this case, our magnitude is 3.4. So we take 3.4 times the cosine of 27 degrees and 3.4 times the sine of 27 degrees. When we do that, we get 3.03 and 1.54. That's all I have to do for number 44. 45, they give us 2 coordinates. We just need to find the component form and magnitude of the vector. So remember, to find the component form, we're just going to take, since we're ending at B and we're starting at A, we're going to take the B values minus the A values. So we did end up with 1 minus negative 6, which becomes 1 plus 6. Then we'd have negative 3 minus 2. So when you go to simplify that, 1 plus 6 is 7, negative 3 minus 2 is negative 5. Now we got to find the magnitude of that vector. So that's the component form. So to find the magnitude, we're going to take the square root of 7 squared, which I'm going to write as 49, plus negative 5 squared, which is a positive 25. When you add those together, we get the square root of 74. So that's the magnitude of the vector. So here it says find the magnitude and direction angle of the vector between 0 and 360 degrees. All right, so to find the magnitude, take the square root of negative 3 squared, which is 9, and 4 squared is 16. And the square root, 9 plus 16 is the square root of 25, which is 5. So the magnitude is 5. So to find the directional angle, that's theta, we take the inverse tangent of b divided by a. 4 divided by negative 3. Now when we do that, you get negative 53.1 degrees. Now we got to be careful, because negative 53.1 is down here. So we got to make sure that that's the correct location. Negative 3,4 is actually over here. So that means, well, if this angle here is also 53.1, theta, what I'm trying to find, is this angle, because theta is always measured from 0. So if I take 180 minus 53.1, That'll give me my answer of 126.9 degrees. So that's our value for theta that we'd be looking for. All right, 47, it says a force of 45 pounds acts on an object at an angle of 65 degrees. A second force of 85 pounds acts on the object at an angle of negative 55 degrees. Find the direction and magnitude of the resultant force. All right, so first off, we're going to do this. The first step is we're going to find the component form for each of these two vectors. So we know theta, we know our magnitude, so I'm just going to set it right up. So it'd be 45 times the cosine of 65 degrees and 45 times the sine of 65 degrees. When you do that on your calculator, we get 19.02 and 40.78. Next, we're going to find the other component form. So we're going to have 85 times the cosine of negative 55 degrees and 85 times the sine of negative 55 degrees. On your calculator, that gives us 48.75 and negative 69.63. So now what we're going to do is we're going to add these together to get the results. When you add those together, we get 67.77 and negative 28.85. So that would be the resultant of those two vectors. So now we're going to find the magnitude of that. Do that over here. So we'll take 67.77 squared plus 28.85 squared. You guys know how to do that. Just so plug that in your calculator, you get 73.65 is the magnitude of your resultant. So that's the second thing that we would do. And then the last thing that we would do to get your final answer, because now we got the magnitude. So now we're going to find the direction. So we're going to figure out what theta is. So to find theta, that's the inverse tangent of b divided by a. So of our resultant, so negative 28.85 divided by 67.77. So when you do that, you get negative 23.05. We got to make sure that makes sense. So negative 23.05 would be down here, and our resultant is where x is positive and where y is negative, so that's going to be down in quadrant 4. So that works for our angle measurements. We would say negative 23.05 degrees. If you didn't like having a negative value for theta, you could always subtract that from 360 and get 336.95 degrees. So either one of those would work. Otherwise, you could just leave it in negative with a negative angle. All right, let's look at number 48. Asks us to find the dot product of u and v, and they give us those two vectors. And then they ask, are they orthogonal or are they parallel? Let's start out with just even answering that last question, are they parallel? In order for them to be parallel, there has to be a scale factor, meaning is there a number that we'd multiply 2 by to get 3, same number multiplied by negative 3 to get 5, and there is none, so these are not parallel. So that's a very easy test to see if they're parallel. Just look to see, do we have a value that we can multiply one vector by to get the others? Do we have a scalar that would make these two equal? And there is none. All right, so now are they orthogonal? For that, we need to find the dot product. So let's look at finding the dot product first. So the dot product, we're going to multiply these two, the first two numbers, so 2 times 3 is 6, and then we're going to take negative 3 times 5 and get negative 15 and add those together, so the dot product is negative 9. Now, if they're orthogonal just means perpendicular. Okay, so are they perpendicular to each other? Are they orthogonal? No, they are not. In order for them to be orthogonal or perpendicular, they have to have a dot product of 0. So no, they are not orthogonal. They are not perpendicular. All right, let's look at number 49. I'm not so worried about sketching them. I just want to find the angle between them. So let's figure out what that angle between these two vectors would be. So that's where we're going to have to use that inverse cosine of the dot product divided by the magnitude of the two vectors. So let's start with the dot product. So just like we did before, we're going to multiply these values and add them together. So negative 4 times negative 1 is a positive 4. 3 times 7 is 21. So we get 25 is the dot product here. So now let's find the magnitude of each vector. So the magnitude of vector u, we would take the square root of negative 4 squared, which is 16, plus 3 squared, which is 9. We get the square root of 25, which is 5. So the magnitude of vector u is 5. Now let's find the magnitude of vector v. So vector v, we would take the square root of negative 1 squared, which is 1, plus 7 squared, which is 49. And we get the square root of 50, which can't simplify. So we're just going to leave it like that. So let's put this all together. So it'll be the inverse cosine of our dot product, which is 25, divided by these two magnitudes. So 5 times the square root of 50. Now, if you're getting these wrong, you might want to take and break this apart into separate parts. So maybe take 5 times the square root of 50, get that answer, and then take 25 divided by that answer, and you should get 0.7071. And if you take the inverse cosine of that, that gives you the angle, which is 45 degrees. All right, so our last question in our review here, we're going to find an equation, slope-intercept form. These parametric equations are these two, and we're going to eliminate the parameter. So the first thing I'm going to do is I'm going to solve for t. There's no cosines here, so I'm just going to solve for t. So I would add 1 to both sides and divide by 5. Now what I'm going to do is I'm going to take that and substitute it in the other equation. Now if you're wondering why I did it this way, I like doing it this way because now I already have it set up in slope-intercept form. I just need to simplify, meaning the y is already by itself. So if I simplify what's on the right, you only multiply the numerator by negative 3 because this is the same as negative 3 over 1. And now I'm going to break apart that fraction to be negative 3/5 x minus 3/5 plus 8. So that way I'm getting closer and closer to get it in slope-intercept form. I just have to combine these two, the negative 3/5 and the 8. So I'm going to change that 8 to be the same as 40 over 5. So now we can get our answer. It'll be y equals negative 3/5 x, and negative 3 plus 40 is positive 37. So we plus 37/5. And that is your equation in slope-intercept form.